well, thank you guys for coming to the June RAC class. Today's topic is night sky journaling, keeping a record and making it easy. Our instructor is Dean Herring, who's a RAC ALCOR. Dean has been with the Raleigh Astronomy Club on and off since 2003. He retired in 2018 from IBM as a mechanical engineer after 41 years and is as a master inventor with over 100 patents. He took a break from astronomy after earning the AL Master Observer Award and went on to build 19 wooden boats while still working. He returned to RAC full-time in February of 2023 and dove right back into the Astronomical League's Master Observer progression, having completed 30 AL programs, earning the MO Gold.
Gold, I just got it today.
Awesome. And so all in all, 30 programs completed and 2 more underway. Okay, and so with that, I will hand it over to Dean, who already has a microphone.
All right, so we had to name this something other than astrologging to get people to come, but we'll get into that. All right, so night sky journaling. All right, Anna, how did I turn this off? Over here, wait a minute. Nobody can see it except me, and it's in the middle of what I'm looking at. Hide. I'm gonna hide this stuff.
You right? And hide non-video participants. Click that.
Hide, we're hiding stuff. Okay, well, good enough.
Okay.
Okay.
There we
All
go.
right, I'm not the AV guy. All right, night sky journaling, keeping a record and making it easy. Safety, we always go through that first. So identify room hazards. We've got all sorts of trip stuff, what we've got. Chairs, bags besides them. We're a little low light here. Anybody CPR in here? Nope, everybody. All right, emergency caller. Okay, we got at least 2. Fire equipment. Well, we're in a classroom here. We will bolt out the door. All right, remote attendees, beware your surroundings. Okay, so night sky journaling, or what is an astrolog? Before I want to, I kind of sucked you in with night sky journaling, but before I want to suck you into the nitty gritty of an astrolog, there's 2 stories, and journaling can be your own simple journal, maybe even just a photograph and a memory, and you can start there. And one of our memories is going to St. Helens and traveling 17 miles through the clouds to get to this volcano. And we didn't think we were going to see anything. And when we got there, there was this massive rainbow over the top of the entire volcano. So we took a picture of that. So that's, that's your night sky, daytime, but it's your atmospheric night sky journaling. One thing that we didn't really journal, but it's really in our minds, was in 2005, we think it was 2005 when we went to Texas, and where was it? San Padre Island, and we went out with a pair of binoculars just to see the Southern Cross. So that was as south as we ever got. So we did see the Southern Cross. So before I get into nitty-gritties of an astrolog, I just wanted everybody to, realize those are your memories. And whether you write them down, whether you took a picture, they're cool. So to get into astrologging, one of the things we want to know is what is up in the sky above us and what time of the season it is. So we handed out a sky map here, and it's also embedded for you guys at home. And so that's evening sky map. Comes from skymap.org. We get one of these, and I hand them out in the class every month at the RAC. And what you need to do is look at your south, your east, your north, know where you are in the sky so that you can plan for what's going on. So right now, what's coming up is Vega in the constellation Lyra, And we're going to say, you know, Cygnus. So we've got those coming up. Summer Triangle is going to be coming up for everybody. Now, this is hard copy. And Al and I sitting here are pretty much hard copy guys. Okay, we're old time. But I did put a couple more links into here. Sky and Telescope has an interactive sky chart. In the Sky org, he has an interactive sky chart as well. There's also Stellarium. Huh? Yeah. So we can just pop to one of these for just a second. Then I didn't open that. So the Sky and Telescope, that's the link inside what you got. Of course, we're going to see ads off here to the side. But basically, they're going to have, I've got this one, and they're going to have an interactive version here. I'm not going to interact with it. You guys can do that at home type of thing or whatever you want. There's also but yeah. See, I don't even know how to interact with this, but I did before I came. So anyway, and Stellarium, I really don't know how to use Stellarium either. So I'm super old school, but you guys don't have to be anymore. All right, so right now we're going to pick out an observing program. And the reason for that, we're going to go to the Astronomical League, pick one out. We're going to pick out the Messier observing program. And here it is here. We've got the owner, Scott Krantz. And what they're going to do is they're going to tell you some background on it. And then they're going to give you requirements and rules. And there's a synopsis over on the right here. I got a laser pointer, so I'm going to use it. Right there. So the requirements are going to be object name, you know, what are you looking at? What object did you go look at? Where are you on Earth? Your latitude and longitude. So this is, I mean, you can either say, I'm in Raleigh, North Carolina, but you're going to find that some of these Astronomical League programs are going to want you to be more specific. What's your latitude, longitude? What's your date? LT is local time, UT is universal time. What's your time of observation? Now, the UT, date of observation, UT is only going to come into play. Well, if you do local time in your 11:59 p.m. local time, you're going to be 0:59, 1:59, 2:59. You're going to have to say 3:59 UT. And you're going to change the date to the next day because the date just rolled if you're going to start doing UT. So you can keep it local time, you know, local date, local time, that's fine. 99% of the programs allow you to do that. Messier is going to ask for a description of the object, and it's going to ask for the size of the instrument used. For visual observation, they're going to want to know the seeing transparency and the power and magnification. So these are rules, kind of rules and regulations for keeping a good log. So we'll go on from there. So we picked out Messier. And here again is they want you to observe 70 to 110 Messier objects. And again, you're going to see the date, time, latitude, seeing transparency, all this kind of cool stuff. So this class is to help you fill that out, hopefully easily. All right, so on the handout, there's a log sheet. So, all right, here's a log sheet. It has everything and everything on it. It's taken me 20 years to get here. Now, what I can say about this one is, let's start at the bottom, where you can see observer, your date, your location, time, I have since blocked out the S so that it's either EST, or EDT now. And D is always going to be daylight savings time, and we're in daylight time. They're calling it daylight time now. I mean, what a mess this is. But anyway, we've got temperature, humidity, C. So anyway, the bottom. I'll teach you how to fill out the bottom. The top is your object, what constellations it is in. Now, strangely, does the handout have RA and declination on top?
Yes, it does.
Okay, so strangely, that went away up here. I don't know what happened, but I always put in the RA and declination. Most programs don't ask you. Most programs don't ask. Herschel, does Herschel? It might. But you gotta be careful on that, yeah. All right, so let's go on from here and we'll break it down. That's what I really want to do. So it can be much simpler than that one too, but let's break it down. So here we're going to take that bottom part where the observer, the date, we're going to break it down. All right, so no worries here. Observer, that's you. The date, that's your date. All right, so location. So how do we get these numbers below? Where are you? Where is your latitude north and your longitude west and your elevation? So the best thing to do is, and if everybody's, make sure, get your phone out and get yourself a compass app. That's what you really want. I don't know which one Dana's got. I've got one here. And if I go compass and I get a hold of my compass app, this compass app, not only, working around for a compass to find where north is, where I can set my equatorial mount up, it also says that right now we are at 35 degrees, 46 minutes, 18 seconds north. So that's our latitude. So if you remember the, Jimmy Buffett song, latitude is attitude. The lower you go down to the Keys, your attitude gets better if you're at the beach. All right, so then west is west of Greenwich, England, which is the 0. So we're west of there, 78 degrees, 39 minutes. Mine also gives an elevation of 390 in Raleigh here. You don't need the elevation, but it's there. So that's how you would fill out your location of north and west. You can also say I'm in Raleigh, North Carolina, and at some other time, if that Astronomical League program requires you to have latitude, longitude, you could say I was in, Al will be in Blowing Rock. And some of his logs say Blowing Rock, and the next one says Blowing Rock, latitude, longitude. I'm like, yeah, he was in Blowing Rock. So that's, or me, I'm in Youngsville. And maybe I didn't put, but so that's how you can get back and forth doing local. All right, so if we move on, get rid of this a minute. We move on to time. Time is kind of interesting. So like I'm going to tell you, I removed the D and the S from here. The D is daylight time. We're in daylight time right now. So one of the easier things to do is use military time. So military time, we're 1:19 p.m., but we would be 13:19. So if you put 13:19 down, now you don't have to put AM or PM. It's military time. So that works. So the only thing you need to do now is know what time zone you're in. So let's go out to the 24-hour clock. So we got the 24-hour clock, and lo and behold, we're at 13:20. And it should give us, at one time it gave us a Raleigh. Hey guys, so get your 4 handouts. So somewhere along the line, it did give me Raleigh up here somewhere along the line before. All right, so that's military time. We know we want military time. That's easier to do. Now, oh, here it is. Let's try this one, time zone. So I'm going out to the time zone. Oh, yeah, here we are. So it's telling me that we are at 1721 UTC. Current UTC, 4 hours ahead of Raleigh. So the Raleigh time zone is daylight savings time or Eastern daylight time. I mean, it's a mess. You just got to know for 6 months and then you got to change it when the time is right to change it. So what you would do is you would have put in the 1320 here. You would have done +4 is a 1720 UT like we just showed when you actually went out to find date and time from this link here. So that establishes that. All right, the next thing is, what's the weather outside? What's your temperature, your humidity, winds, clouds, other can be smoke. We've had a lot of smoke down here. Moon phase, you're going to want to know the moon phase and either the rise and set time. All right, so, you know, you can look at your own thermometer. You can guess that you've already got dew. You can write down some of these things. Or what I usually do is I go to clear outside. And we'll bring this up. And yeah, Dana, we might be clear out tonight at 11 o'clock. So here's clear outside, 11 o'clock. All right, so this is showing forecast for Raleigh, Wake. I want you to look at what we've got here, especially this Bortle. Class 8 Bortle, right where we're sitting right now. So that's not good. But we'll get into that. So what this does is it's going to say Saturday. Oh, here's your moon. It's a waxing crescent. So the moon is coming on, 14%. It's telling you that it's going to set at 11:22, 23:22 tonight. So if you think about when this moon is going to set, it's going to set in the west. So you're going to put your arm out. You're going to go, this is going to set in the west at 11:30. Gee, by the time I go out at 10 o'clock, it's a few degrees up, but it's not going to bother my targets because I'm not going to be looking at a west target. I'm probably going to be looking at an east target, a south target, a north target, and I'm going to be fine. But by 11 o'clock, I'm not going to even know the moon has been up anymore. So that's kind of how you kind of read this. And then you look at the next night. Ooh, it's waxing, 23:49. When it says no set, and we get to next Tuesday, it actually sets at midnight. Then it sets at 12:36 a.m. on Wednesday. Now, a lot of times what I'll do is I'll look at Sky and Telescope magazine or the Astronomy magazine, and they'll have the date, they'll have a moon phase, and they'll actually have a sky chart that you go to the moon on that date and you go up the sky chart to see what constellation the moon is in. So if you're after the constellation of Lyra, I can guarantee you by the 15th of July, the moon is going to be right in the middle of Lyra. You're not going to be able to do anything. So that's kind of how you read this. And so what you can do with this is the night you're going to go out tonight, you can fill it out and say, hey, it was 14%. And oh, by the way, it's set at 23:22. So I wasn't worried when it rose, because it rose at 9:17 Today, yeah, because it rose at night. It's got to be out there then. Yeah, it's out there as a thin sliver somewhere in the sky. All right, so let's expand this. So if we expand this, what we're going to see is clouds are going down, total clouds, low clouds, ISIS, Passover, visibility, the fog, precipitation, amount, wind speed. All right, here you can get the wind. I mean, if if you're going out there at night and you're like, now put your finger up. Yeah, no, I got nothing, or I got something. Well, you can go back to this and go, it was 4 miles an hour. Or you can fill it in beforehand and say, it's going to be about 3-4 miles an hour. Temperature, 28 degrees Celsius, dew point, 19, relative humidity. So here's the number you want right here. 60, 63, 64. What I do is I go out, I put it in Fahrenheit. I'm not a Celsius guy. But let's say you've put 28 degrees Celsius and I put an arrow next to it indicating it's dropping. I'm not going to keep every single log. I'm not going to put down the exact temperature. I'm just going to say when I started at 9:30, it was 28 and it was dropping. And I'm going to put down on my logs that it was 60% humidity and rising. So I'm not going to put, on every log is not going to have every single temperature per the minute, per that log. It doesn't need to. You just want to get it close if you want to keep track of these things. Because I've kept track of these things in such a way that when I was imaging something, and also on the log you might see, or you might want to put the altitude of how high in the sky it was. Because what I've noticed on my logs now, of especially imaging, that when I go and look at an image and it's an ugly image, it's just background is some weird color. It's like, oh, that was only up at 30 degrees. The humidity was 70%, and it was a really ugly night. And I was shooting through a heck of a lot of atmosphere. And that's why 3 months later, when this object was up around 60 degrees or 70 degrees in the sky, my picture looked so much better. All right, now I remember why. So that's something you can do. So there is how you get your temperature, humidity, wind, clouds, your moon phase, rise or set time. The rise time is going to be waxing gibbous to full moon. And that son of a gun is going to be rising at 9:30, this time of year, at 9:30, at July 20th, probably, or July 18th, let's say. And so you're going to want to know that the rise, you're going to not care when it sets because it's not going to set. It's going to be up all bloody night for you. So that's kind of why you just do a rise or a set, whichever is cleanest for you to put on your log. All right, how dark is my observing site? Well, we don't need to say, we just came out of clear outside. We saw where the Bortle class was. It was literally in the headline of Raleigh. So that was a Bortle 8. How much meaning that it has to you? It almost matches the mag of your sky. And the mag of your sky is what is the dimmest star I can see. And Bortle 8, you could probably see a mag 2 star. So we really want to go to mag. And light pollution is our problem. So let's find out how clear and steady are the skies above me. So seeing is going to be something out of 5. Transparency is going to be mag. So let's go to our laminated sheet. And we can also, so the laminated sheet is something I made from the Astronomical League Seeing and Transparency Guide. So if we go out to that, to the Astronomical League, you'll find that they put out a guide. And you can go deeper into seeing and transparency than they do here. The Astronomical League, for things we want there, only require you to do seeing as excellent, very good, good, fair, or poor. And transparency, thereafter, what you can see in the Little Dipper. So if you turn the laminated sheet over, you've got the Little Dipper on the back. So even in the worst, well, the worst time for me, and didn't we see, no, we were doing good with the Big Dipper at the Willard. The Little Dipper, not so much. But so, so the Little Dipper is you want to get at least see Beta Kochab is mag 2. If you can at least see that, it's mag 2. Gamma Ficard is mag 3. I'm butchering these names. And Alpha Polaris is 1.97. So on a really, really bad night at my house, really bad, I can only see those 3 stars. So if you can only see those 3 stars, you're in mag 3 skies. Most of the time I can see mag 4 to mag 5 skies, and I usually put down my mag is 4.5.
Indeed. And when you're saying magnitude, you're saying basically limiting magnitude?
The dimmest star I can see. And if I see that star averted, I'll write down, I saw it averted, right? I'm not looking directly at it. I'm looking just above it. I got it. I can see it. So for me, that means somebody with 20-year-old 20/10 eyesight can see that thing straight on. So that's going to be the mag of the sky. All right, so I think the next sheet for the others at home, you can print out that what I'm showing in class here on the back and the front. And I always have them laminated at the meetings as well. So the front of the sheet matches the Astronomical League. How good am I seeing? What's twinkling up there? And how transparent is my sky? What I can see of the Little Dipper. The back of the sheet has this Antonade scale. I'm just going to say it like that. Which is perfect seeing, slight undulation. So this is a 1 out of 5. So that's kind of what that's kind of what seeing was here. You could put that scale here. It's a 1 out of 5, and it matches excellent. 2 out of 5, slight undulations, matches, very good. You can put excellent, very good, or good. So that's subjective to your viewing and your sight, how you're doing there. So that's seeing and transparency. All right. So we're not going to dive super into this. The next thing on the list, after you've done all that, so you basically filled out the bottom, and you only need to do this for your first sheet of the night, because you can do the rest, during the daytime later. You filled out all your bottom of the sheet, where you are, the temperature, everything. Then what you want to do is put your equipment in. So I've got an equipment example. I've got a 150 millimeter Newt Dob. It's 150 millimeter mirror. I got the focal length. So are we going to star chart hop? Are we going to use a digital setting circle? Or are we going to use a full go-to? So since I've got a Star Sense Explorer, it's actually a digital setting circle. I can key in the object. Yeah. Each observing program is much different. the beginning Messier visual, I think, is all star chart, isn't it? It's all star chart because in order to earn the master observer progression of observer, they want you to at least know how to use a star chart before you go to digital. You know, this is the progression: star chart, digital setting circle, then go to. So each program will have something different. Of course, if you're doing Messier imaging, and you can do that with the C-star, that's going to be go to. That's go to. That's, you know, imaging is go to. All right, so that's how you fill that out. I had a 20 millimeter eyepiece. I didn't have a Barlow. Now, I had an eyepiece that has an apparent field of view of 68 degrees, all right? So you could get a Plossl eyepiece, apparent field of view is going to be about 52 degrees. Super Plossls are going to be maybe 62 degrees. You're going to know when you buy this eyepiece. It's going to be the spec of the eyepiece. And a Nagular eyepiece is going to be 82 degrees field of view. So they're going to be way out there. All right? You had a question on that one, Blair?
I was curious what you mentioned.
Well, these are just different. Yeah, it could be 52, 62, 68, 80. There's all sorts of numbers. If you got a different number, put it there. Right? So you're going to know when you get your eyepiece. That's a different animal altogether. The field of view of the C-star is predicated on the size of the sensor and the size of the aperture and the focal length. I'm sorry, it's predicated on the size of the sensor and the focal length. All right, so, and we'll do that next. All right, so the magnification is your focal length divided by your eyepiece, 37 degrees. That doesn't tell you how much of a field of view you can see looking through that eyepiece. So what you do, the field of view of that eyepiece, when you can put your eye into it, you have 37 magnification, but how much of the sky are you seeing? And when you look at a star chart, you're going to want to know that, especially if you have to find the object with a star chart. It's going to become very important if I'm looking at 1 degree, 1 degree on a star chart, 2 degrees, what am I looking at? The more you magnify it, the harder the star chart gets to use unless you know your field of view. So the field of view for this particular setup, for this 20 millimeter eyepiece that's got a 68 degree field of view is going to be 68 divided by the magnification. So it's going to be about 1.8 degrees eyepiece apparent field of view. So when you look in that eyepiece, you're going to be looking at 1 point from the top to the bottom, 1.8 degrees. So this is handy if you start to describe, let's say, a galaxy that takes up half of the field of view. We're going to know it's 0.9 degrees or 54 arc minutes. Let me know if I lost anybody. I lose you yet? You're not into this yet. All right. It comes with time. Right now, we're just filling out what our instrument is. All right. So if we go to imaging equipment, now we have the same. We have a Newtonian with a 600 millimeter focal length. We're going to use go-to. We've got a ZWO-AM3 equatorial mount. Let's go to. We've got a camera, which is a 183 Pro. We had to look up the sensor. The sensor size is 13.2 by 8.8 millimeters. The diagonal is 15.8, 2.4 micron pixels. What we need to know, we put a focal reducer on it, 0.86. Our final focal length is 518. We don't have a filter. We've got a field of view of 1.5 by 1. I didn't put in how to calculate this. So how are we going to calculate? We'll figure this out. We'll show you how to calculate this as we go. Huh? We're going to cheat. All right, so we're going to acquire a target that's up there tonight, which is the M57 Ring Nebula. We're going to go to Telescopius. Let's go out to Telescopius. This is a cool place to go. All right, up here. Here, hopefully I'm going to put in these examples. We are going to have a telescope. Is this telescope? No, we're going to, let's see, eyepiece. Let's see, eyepiece. Okay, so we're going to go to eyepiece view. We know we have a telescope. We said it was 750 millimeters. We said our aperture was 150 millimeters. We didn't have a Barlow in there. What?
You have a reducer.
Did have a producer.
Same spot.
I had a reducer in the imaging. We're doing the telescope that I had. So we had a 20 millimeter. We had an apparent field of view of the eyepiece. Apparent field of view, magnification 30, real field of view. We had a 68, which is 1.81. Field of view, real field of view, 1.81. We want to go to M57 up in the sky tonight. Planetary nebula. Lo and behold, that's what we're going to see. All right? So, pretty tiny. In order to change this, we're going to have to go to, let's say, a 5 millimeter. Is that the eyepiece? Yeah, that's the eyepiece. A 5 millimeter eyepiece. So a 5 millimeter eyepiece is going to get us something closer to this. It's going to, so, all right, so now look at our field of view, 0.45 degrees. So from here, from the center to the edge is 30 arc minutes. Half of that is 15 arc minutes. Half of that is 7.5. So this thing is only about 5 arc minutes in the sky. That's the size of it. So that's why it's important to understand what the size of everything is up there. All right, let's yes, sir.
Just to let you guys know, that website is really awesome for a lot of things. Like if you want to see what's up tonight, it's got targets up there.
Yeah, it'll do a whole lot of this stuff. Yeah, no, it'll do a whole lot.
I go outside and I have a little, you can also make a list of targets, make sure they're all up at the time you're going to be out there. It's really good for that. Sorry, I didn't mean to interrupt you.
Yeah, no, that's a whole nother deep dive is how to plan for this stuff.
Yeah.
Oh yeah, it has binoculars. You can. No, we didn't do binoculars.
I was just sure. This does it.
Yeah, it's a huge site, just filled with cool stuff. So in the Groups IO, on the Astronomical League subgroup, you want to be a part of that. And if you joined the club, you were automatically made a part of that unless you opted out. It has the class, today's class, and I did put this entire PowerPoint in there that has all these links and everything so you can get there. So you don't have to memorize it. All right, so let's go to the imaging one. I don't know why it came out of there. Let's go back. All right, so now we're going to do the imaging one. So we're going to go to astrophotography. Let's just go to our mosaic. Let's just go to our target. Where's our targets? Target, here's our target. So we're gonna go M57. M57, a ring nebula. Let's just go to the target first. All right, so we knew this thing was what, 518 with the Barlow, whoops, I got to key it in here. 518 with the Barlow in. I'm not going to say it's the Barlow. 150, okay. And that was our sensor, 13.8 per 2 by 8. That's our sensor. What is this thing? Mosaic. We don't have a mosaic. Okay, well, that's what we're going to see. So we've got a, okay, so all right, here's where I cheated. Forget the field of view of what this sensor delivers, which is 1.46 by 0.97 degrees. So that's how I got that, because there is a different calculation for this versus the eyepiece, apparent field of view on eyepiece. So that's how I get it from here. The field of view for binoculars. All right, binoculars, right? Field of view. It usually says so on it. General, full screen. I don't know how to set binoculars up with this one. Survey, no. This I don't know.
No, I just asked.
Yeah, if you had a 70 by 50, I don't know where you put it. You put it in here somewhere. I know that. Yeah. Yeah, I mean, if you log on, you can put all your own equipment in.
Yeah.
Beth asked a question online,
Oh, yeah, okay.
and I hate to go back, but I didn't want to get too far away. She was asking about using transparency from an app like Astropheric. And I was going to say, if you use an app, it tells you what like the weather app, it'll tell you what they think it's going to be. But if what Dean was showing on his transparency and seeing guide will tell you what you're actually seeing at the time you're there that you're observing. So it's best to use that than an app telling you what the transparency should be there. Would you agree with that?
There's some leeway there, but yeah.
Yeah, I know.
Especially if you didn't write down seeing in transparency and you're going to go back. Yeah. Go back and find it on one of these sites and put it in the log. Not hold against anybody.
Seems to be very optimistic. Somebody who considered good or very good transparency is not really they see. Or, well, yeah, actually, I was meaning seeing. But like, for example, it was considering, even if the planets are flickering a little bit, that's very good. It's like,
Yeah, it says that's very good. Their seeing guide says it's very good if a planet is just flickering. It's like, I don't think so. That should be the planet not flickering.
Brighter planets are twinkling like twinkling at all, it takes it down.
yeah, but
Right.
in my opinion,
Yeah, really. I don't disagree with that. All right, so if the planets are twinkling, you either have low level wind or high level wind. I mean, it's wind between us and the sky. All right, let's get off of this one. All right, so I'm not going to get too far into this. How are we doing on time? We're in pretty good shape. So sketch it. Everybody can go here, but sketching requires the observer to slow down long enough to record what is being viewed. And so it requires some more time and concentration. And I'll tell you that what I'm doing and what Susan and I are doing lately is we are also sketching from an image because that allows us to describe at the same time we're sketching. You know, it helps. That type of thing. I mean, what are we actually seeing? You can look at that picture for 1 second, but you can look at it for another second and, you know, go, oh, well, this galaxy has a lot of modeled areas inside of it that I didn't notice before. When I'm looking at the, you know, the image, I can see, you know, a dust lane that we didn't see before. So, and we do have some sketches, and they don't have to be, you know, they don't have to be good. None of mine were good. 20 years of sketching, none are still good. All right, but you can find, so let's just go here. They just show it. They just say, look, there is an absolute sketching program, and I had to do it to make Master Observer Silver. Yes, silver. And the sketching program is put out by this lovely gal in Hawaii whose sketches make the headlines. They're so good. She's been in Cloudy Nights sketching contests before, winning that. Her sketches are just, my sketches were so horrible, but she was the one that had to approve them. So I did get them approved. Anyway, there's an entire sketching program. And the nice thing about this program is actually that the observing list is nice, bright, Messier Caldwell objects mostly. So it's none of the esoteric objects. It's things you can see nice and easily out there. Probably 10 sketches of lunar surface, those kind of things you can do. The only thing I did new for this one was I did use what the white pencil on black sheet, which was really cool. All right. So we're not going to get into sketching. The next thing is describing. So there's an entire place on the Astro League log. It's called the Description Guide. And, you know, it's asking, is the object round, oval, irregular shaped? If you had M57 in front of you from what you just saw, you would go and you would go, oh, it's oval shaped. I kind of see an oval. If you were to do M42, the Orion Nebula, you would definitely be going, but this is irregular shaped. Does it have any sharp edges? Does things gradually fade out? Is there a brighter core for globular clusters? Is the central area large and full, or do you see pointed stars? Now, if you have any books like Night Sky Guide or the Orion, First Steps Orion Guide, it's a big one. Yeah, if you look in there, they're described. Every object has a description from somebody else. So you can see how they are described by somebody else. That happens. So each Astronomical League program does ask you to describe. I don't think there's one that doesn't ask you to describe. Every single one that I've seen asks you to describe something you're seeing. So you'll get better in time. You can describe things like, wow, that was the best thing I've ever seen. I mean, what, you know, it's your log. All right. And then right after that, you go, it's oval. That was cool. It's oval. Okay, now what I'm going to get into, what I'm going to finish this off with, is almost one of the most difficult things to understand. Which way is west? Because everything wants you to describe You put in your sketch, you drew some dots. Which way is west? All right. So, what did I give you guys? So I gave you a small one. So let's start with the big one first. If we're looking at a terrestrial map, there's our map. I'm looking down at the Earth. North is this way, going to Richmond. West is going to Asheville. East is going to the coast. South is going to Atlanta. I got it. That's pretty good. All right, I'm looking at a star chart. Here's the mistake you make with a star chart. You're looking at the star chart and you're looking down at the Earth. And it's not right. Star charts are meant to be looked at in the sky. Look at the sky, and I look at the terrestrial map. I'm going to look at the sky. Terrestrial map's a mess. Let's look at the sky. And we're going to face south, all right? We're going to look at the south. We're going to face south. So all my objects are coming up here. That's east. All my objects are going down there. That's west. So west is the same way. Matter of fact, oops, it fell on the ground. Matter of fact, if I stand in front of the star chart here and I'm looking to the sky, west is this way. West is still west. It's still west. And east is still east. Only I'm looking at the sky. All right? So now, so that's how you look at a star chart. So then what happens is we're going to dial in a little bit more. And we're going to look and we're going to say star drift direction out of the eyepiece view is always west, no matter what you're looking at. Always west. So, view through a Newtonian reflector or straight through a finder scope, all that happened, and take that sheet out that I gave you with the chart on, and look at the top one, all right? Turn it upside down, and that's what you see in a Newtonian. So that's going to be your view. And so in a Newtonian, when you're looking, almost always every time you look, you sketch and you went west was either this way or this. It was somewhere to the left, unless your scope is pointed west, and that's a whole nother story. That gets more difficult. All right. Now, if you use the Newtonian, like I know you have it a lot, when you're looking at this star chart, and you look at these, look at shellac, and see the two stars above it, and you're looking in your Newtonian, and what you do is you take your Newtonian and you raise it up because that's what you see in the star chart. And what happens is you just went north. You just went and looked at everything below shellac. You did. So when you're actually using the Newtonian, you need to just remember that in the eyepiece, these are above, which means they're south, and I got to lower the scope. So that gets wild. All right. Now, view through an SCT or a refractor with a star diagonal, and that means either one. This is probably this is an SCT straight through over here. But an SCT or refractor with a star diagonal, that's the bottom one. North is up on your star chart, but west just went the other direction on the star chart. So when you look at a refractor, And we're looking at shellac again, 2 stars below it. When we lower the refractor, lo and behold, we're going in the right direction. But if we do east to west, we're not. We're off to the star chart again. So the only real thing to remember is when you're at the eyepiece, you indicate west. And then the next day, you may need to remember, oh, it was a Newtonian. And when that happened, I go to this chart and turn it upside down. West was this way, and north was down when I indicate west and north. So these things taking me, west has taken me many years to, to get correct. All right. That's about the last one there. Oh, I'm sorry. And I did give you the big 4-degree star chart that you could look at. Just kind of shows you what's going on with the Ring Nebula. All right, well, that's the big picture. What I want to do is just show you a couple more logs that got simplified. Are they up here? Oh, they must be here, right? Observing log. Nope. I might have to go to them again. All right, we know how to do that. You right click. And let's see, right click. Huge slide screen, presenter option. Nope. Oh, wait. Anna showed me how to do it, man. I don't know what's going on. Huh. Well, we're trying to get to these. They're simpler. Let's see. Control. No, it was right click for sure. Alt right click. No, shift right click.
So that you guys know while he's looking that up, if you look at a telescope, everything's inverted. Okay, so when you look in a mirror,
Yes.
same thing, except that's called perverted. So now you're looking at a pervert every time you look in the mirror.
Always root for you.
I was waiting for the dad joke. It was gonna come sooner or later.
And you missed it.
And I missed it.
Yeah, we're failing here. Yeah. All right, sorry guys, we failed. This one is Mino telescope. It's much simpler. This one was just for imaging. And this one was for double stars, and it's much more complex, and it's sitting on the table back there if you want to do double stars or multiple stars. Because then we have to get into the position angle of one star versus the other. All right, interesting. I actually asked Chat GPT, one of the first things I said, make me an astronomical observing log with a sketching section. And it did, and it almost nailed every single thing that it needed. So it's not intelligent in itself, right? It has been loaded with hundreds of other people's astronomical observing logs that it's gone and cherry picked and made its own. So that's pretty cool. Or there's one from an AL observing program, or your own notebook. What'd you see when? Grab what you saw. I mean, I've made this pretty much for Astronomical League, but you just have a diary if you want. Don't have to be. All right, RAC resources. Navigate to observing programs where others in the club, and it's actually underneath about observing programs. And you can get down here to club awards. And I didn't know I was going to do this, but club awards. We're going to go that route. All right. Al, Sunspotter certificate and pin. All right, there you go. All right, we've got some Hubbles, and this fella is a month behind. I don't know why. He's had some issues. Blair, Night Sky Hubble Challenge for May. Go. Dana for May. Pete Herring for May. Susan Herring for May. And I got nothing for you guys. All right, here we go. All right. Mustafa, we have March silver, we have January silver, and we have April silver, and he's already got his February. Very good. All right, now for the big one here, we've got Adnan, and this is interesting for the rest of us who haven't had this happen. He's got the eyes only certificate for lunar, the binocular portion of the certificate for lunar, and the lunar, along with a nice pin and a nice letter from the serving program owner. And we got March and April certificate. All right, congratulations. Well done. All right, I'm done.
Get out there and get your stuff done.
All right, now we're done. All right.
Questions? I got any questions? What's a goat? What is a goat? You asked me that. What's a goat?
His question is, what's a go-to scope?
Oh, go-to scope. All right, so here you are using your dad's scope, and he's got a chart in front of him, and it says M57. And if you tell him to put a motor on it, and an encoder, and a computer, then we can go M57, and it'll go to and track it.
How does it know where to track?
Oh, well, first he needs to know where it is, latitude, longitude. You're in Burlington. Needs to know what time of day it is, that it's nighttime. So it needs to know where it is on Earth, what time of day it is. And then most of them, you need to teach a couple bright stars. So a lot of them you would then say, it would have a little computer screen, and it would then say, okay, I know what time of day it is, I know where I am on Earth, I'm level to the Earth, but I need you to tell me to point your scope at Arcturus in Boötes, and then I need you to, when you point it there, I need to hit, yes, I'm on it. And then I need you to pick out another star, let's say Vega in Lyra, and I need you make the scope go to it, pick out Vega, hit enter, then the computer goes, oh, you've picked out, it's called two-star alignment, it's one of the early things. I now know where two stars is, and I'm going to look at my internal database star chart, I'm going to match it up, and now I'm going to go, oh, where do you want to go to now? So that's how they work. Work on your dad for one of those.
Like that, you can then say, okay, go to this other thing, and it knows where it is and what time it is, so it can that in the sky for you.
So a C star is another level that you don't have to teach it 2 stars. It sits there. The only thing you have to do with it is level it, because it sits there. It has a GPS. It's like it sits there and it goes, "Oh, please level me. Oh, you leveled me. That's great. Thank you. Oh, I know where I am on Earth. I know what time of day it is. I'm going to look up the sky myself. I don't need you. I'm going to look up at the sky. I'm going to take a picture of the sky, 300 stars, not 300 stars, and I'm going to compare them to my internal database, line it up, and now I'm going to tell you, I know where I am. Where do you want to go to?" And so that's called,
Do it to me. It's
I-
Yeah.
yeah, plate solving. Sorry. I can't remember plate solving every single time. I can't remember the word plate solving.
Plate it, that means eat, so I can.
how I do it.
Those log sheets on.
Oh, I can, yeah. They're on Groups.io as well.
Helpful that you helped.
Yeah.
When I first had to do like filling out the log sheet, and I don't like to write. You know, I don't like to write like a paragraph. Way out loud. Okay, I don't like to write a lot of paragraphs. Some of the things that he helped me with is to do bullet points, which helped me tremendously in my explanations. Because the first ones I did when doing Messier, I did like a paragraph, and it's like, nobody wants to read that.
I'm like, what are you doing?
Nobody wants to read that. So the second, then I started doing that. And another thing was because I did Caldwell and Messier and imaging. You were talking about sketching, and I sketched 90% of each of those imaging. So I imaged, I sketched, and then I described, and it helped me. So now that I'm doing like asterisms and I have to describe and I have to draw, it's helped me visualize it more, you know, because you're doing like with the asterisms, we're doing binocular, naked eye, and telescope. So that's all I just want to say.
Yeah.
It's very helpful as a beginner to do all 3 things. It takes a few more minutes, but it really helpful.
And I've got asterisms over there on the table there, how I plan for them, some sketches, those kind of things. I just heard it.
Actually, speaking of imaging, I've got a question for you, and this was only because of a Hubble, but I noticed that, you know, doing like planetary nebulas, since they're incredibly tiny, and using the C star, you know, they're almost, you can't even tell they're there. And I was noticing, I think it was Susan's had like zoomed in or cropped the photo to make it larger.
Yeah.
Do you have to redo the field of view that you've got when you zoom in?
Nah,
Because I didn't want to do that.
no, just try to zoom in.
Okay, so you can zoom in, but you don't have to adjust because now you're looking at a different field of view.
You can say that on when I fill out those log sheets, it actually says like 1.5 degree field of view. And then over the sketch, I change the field of view to what I think it is, 15 arc minutes, 10 arc minutes, and I try to draw it bigger or something. And the same with the image that I blew up. When I cropped the image, I cropped it, I put it out front, and I estimated what the new field of view was on it. But the resolution's not any better. It's from the same picture.
Image that I'm actually doing it from the
Yeah, it's not done through the native C star. Just done through some other program. I just cropped it and blew it up and stuck it on there. Yeah. Yeah.
Because like I know what the clown nebula, the clown face nebula, I didn't even know that I got it.
Oh,
And,
it's
and,
tiny,
and,
yeah.
and, yeah, Naveen is like, oh, it's right there.
Actually, I think it's the Quattro.
Yeah.
That's the one I did.
Anybody got any more questions? Shut us, man, we're over.
I think we're good.
Oh, I'm sorry.
Thank you, Dee.
All righty. All right. All right, yeah.